Hello. In this video, we're going to go through an example that involves compound triangles. Compound triangles are cases where triangles have been put together to make some larger shape. So what happens is often the two triangles share a common element. And in this case, the common element is this length right there. So I want to solve for x in this diagram. So the first challenge I see in this problem is that I'm going to have trouble explaining myself because I haven't properly labeled this diagram. So the first thing I would do if I got this problem is I would actually go through and at each vertex I would put a letter. And this is going to allow me to properly communicate my ideas. So now we see we have triangle ABC and we have triangle BCD. Okay. The next thing that's really important in these types of problems is to identify those common elements. So in this case, this length BC is the common element. So I'm actually going to label that. Now this is where the question often comes. Well, if the triangle naming conventions say that we name length to correspond to the opposite angle, if we think of triangle ABC, then if this is angle A, this should be length A. But if we think of triangle BCD, if this is angle D, this should be length D. And this is a case where we have some flexibility in that rule. We don't need to name it A or D. I'm just actually going to call it whatever I want in this case, and I'm going to call this Z. As long as I put the name on the diagram, I'm okay. I could call this length BC if I wanted, but I like using a single small case letter. So now, the starting point in this problem. In order to start working out other values in a triangle, I need to be given at minimum two pieces of information. So if I look at triangle BCD, and that's where x is located, I see all I have is this angle right there. So I need to find a second piece of information about this triangle. So that leads me to go back to this triangle and take note of the fact that I now actually have two pieces of information about this triangle ABC. I have length 7 and angle A. So if we now talk about this triangle with reference to angle A, Z would be the opposite and 7 would be the adjacent. So therefore, we're going to use the tan ratio. So tan of 40.6 degrees, don't forget that degree symbol, is the opposite, which is Z over 7. So Z is approximately, that's not yet approximately, Z is equal to 7 times tan of 40.6 degrees. So Z is approximately equal to 7 times tan of 40.6, 5.9997. And if I round this to 3 decimal places, I get 6. So if we write this as 6.000, I could put just 6. So we know Z is approximately equal to 6. And now what I'm going to do to help communicate my idea is I'm actually going to write step 1. Find Z. Okay, so now that I know two pieces of information about triangle BCD, I can find x. So now, if we're going to use this angle C, relative to C, x is going to be the opposite, and Z is going to be the hypotenuse. So notice how relative to angle A, Z is the opposite, but relative to angle C here, and we should more properly say this angle BCD, Z is the hypotenuse. So if I have the opposite and hypotenuse, I want to think of sine. So step 2, we're going to find x. So therefore, sine 31.48 degrees is equal to the opposite, which is x, over Z, which is 6. So therefore, x is equal to 6 times sine of 31.48 degrees So let's come up here. So x is approximately equal to, and I'm going to come over here to my trusty calculator, 6 times sine of 31.48 equals 3.13. So it's approximately 3.133. Whatever the units happen to be in this case. So now I'm going to take my red just to help show this. There's my final answer. So now I'm going to ask myself, does this make sense? So if angle A is 40.6 degrees, we know angle ABC has to be larger than angle A, so therefore Z should be less than 7, because since this angle here is larger than this angle here, this side here should be larger than this side here. That makes sense. I see that this angle is 31.48, so the angle CBD, which is right here, is going to be larger than that. So, oh wait, let's go back here, sorry. Let's look. D is a right angle, so Z is the hypotenuse, so my answer for x has to be less than my hypotenuse. Yep, that's good. So my answer makes sense as far as the values on here. Now one last little point with this problem. One thing you could try here just to practice your calculator work is, you see here how we have, and let's actually change my color again. Let's change it to a color I haven't used. Let's do pink, shall we? You see here how we have Z is equal to this? One thing we could do here is notice how here we've put Z right there. I could actually write this. I could say sine of 31.48 degrees is equal to x over, and instead of putting the value 6, I'm going to actually write 7, I'm going to scroll over a bit here, times tan of 40.6 degrees. So 7 times tan of 40.6 is just a number, so I can multiply both sides by that. So x is equal to 7 times tan of 40.6 times sine of 31.48 degrees. So x is approximately equal to 7 times, I'm going to type this in my calculator, tan of 40.6, close my bracket, times sine of 31.48, close my bracket, equals, and notice I get the same answer. So we get approximately 3.133. Again, for this problem, not a big issue. However, it's nice to be in a position where you're comfortable substituting in this manner, because as your problems get larger and in different mathematical situations, this type of process is really helpful. So I hope that video helped. As always, if you have any questions, be sure to let me know. Have a wonderful day.